In this episode of the On.NET Show, we're going to have Phillip Carter coming back again to talk about what are some of the new things that are inside of F# 4.5. Welcome to another episode of the On.NET Show. My name is Phillip, and I have joining me again, Phillip Carter.
Hi.
What's going on, man?
Not too much. Just having a good time.
This is like your third time on the show now, right?
Yeah, well, back in like the early days of the show, I was on there for a few times. I did a few like 2-hour-long F# ones.
Oh, wow.
It was, yeah, those were a little out of control.
Wow, that's a lot of F#.
Yeah.
So what are you here to talk to us about today?
So I'm here to talk today about F# 4.5.
4.5. So
Yes.
I think the last time that you were on, we were at F# 4.1.
Yes, 4.1. So we jumped up a few digits.
Okay.
Well, decimal places, I guess.
Decimal points.
Yeah, so it's actually kind of interesting because the last version was F# 4.1, but now it's F# 4.5, and so you might be thinking, well, what happened in those 4 places?
Sure.
Well, versioning is something that's always fun, and everybody always gets it right every single time.
Of course.
Yeah, so there was some really interesting historical stuff that occurred in the past with F# where basically F#, the compiler depends on the F#.core binary, which is sort of its core library. It's got like definitions for like what an int is, what void is,
sure.
Things like that. And there's been some new additions and things like that as time has progressed. But up until, it was all like just one thing until you got to .NET Framework 4.0. And so then there was sort of the split between like, .NET Framework 4.0 world and previous world. And because it was a different runtime, there was then a different version attached to that binary. And so you would get version 4.language major version .language minor version .something. Right. And then there would be an older one. And then time progressed, and then NuGet got more and more like a central part of developers' lives with .NET. And there was a NuGet package for F# core. And that version number was not the same as the actual binary. Oh. And that got even worse as that NuGet package then revved sort of like, somewhat semantically, so that like as there would be different minor versions as new things would come in, but it would carry a completely different binary. And so you had this weird world where at one point I believe we had F# language version 4.1, F#.core binary version 4.4.1.0, and F# core package version 4.3.4. So that made no sense to anybody.
Right, so the version was a little crazy there.
Yeah, and that was just something where like just standard engineering processes of versioning stuff just sort of led down that path, and we're like, whoa, okay. So the only way to reasonably progress forward and sort of have a version number for everything that was at least sort of aligned about major language version, minor language version was 4.5. Okay. So now we have F# language version 4.5. F#.core NuGet package version 4.5.patch, and then we have F#.core binary version inside of that NuGet package 4.5. Whatever. Sure. And so they're not exactly the same numbers, but like at least they have the first 2 digits that are the same, and we intend on keeping it that way from now on.
Sure, it's a little bit more consistent now, so it's easy for people to see like what pieces go together.
Yeah, and that's one of those things that like starting out as an F# programmer you never really ran into as much, but then once you started caring about like, okay, well what binaries do I actually have? Yeah. Boom, like big confusion. So hopefully this makes things a lot nicer.
Nice. Yeah. So why don't we talk a little bit about where exactly we could get started and where can we actually get these bits from?
Yeah, absolutely. So we got a handy dandy website right here, the .NET homepage, and there's an F# page right here that's just, you can actually visit it if you go aka.ms/F#home. Okay. That'll just take you there. So we got a nice little tagline, and most importantly, a big old button that says Get Started with F#. This will have you download the .NET SDK, which has .NET Core and all that stuff in there. And this will give you the latest ones. This will give you F# 4.5 inside of it. So basically, if you install .NET Core, you already have F# actually. But if you don't have .NET Core for some reason, this is definitely the easiest way to get started because this will work, obviously cross-platform. It works inside of Visual Studio, works in VS for Mac, VS Code, basically anywhere you want.
So not only do I get the F# compiler and F# tools, but I also get the templates as well, right?
Yeah, yeah. So you get some basic templates out of the box with the .NET CLI. So like in this case, the little tutorial says, .NET new console -links. That's like a little console app. But there's like ASP.NET Core ASP.NET Core templates, like library templates, and then if you want to use other stuff. Like there's a fantastic library called Giraffe, which is for building web services on .NET Core. It uses ASP.NET Core stuff under the background. Well, they have their own templates, and so you can actually use the .NET CLI to just do .NET new. Well, there's like a way to install templates from a NuGet package, and so you can just have that. And then so there's also a lot of community stuff out there that you can get by using different libraries. So.
Right. So I remember in a previous episode, you did come on and talk to us about Giraffe a little bit. So we can make sure that we add in the show notes so everybody can take a look at that episode and see all the good stuff you do with Giraffe. Yeah,
absolutely. And I think Giraffe recently reached version 3.0 since that video, so it's pretty stable. I recommend trying it out for sure.
Nice. Sounds good.
Yeah, so that's basically just how you get started. Now, you can also use Visual Studio, and so I'm just going to move on over there. So if you use Visual Studio and you get the latest stable version, so that's 15.8, I think it's .6 is sort of the update version right now, the update patch. If you download it, that'll be the one you get. This comes with the exact same binaries, like the exact same core library compiler as you would get in the .NET Core SDK. Actually, this will install that same .NET Core SDK that you download from the site. So if you're on Windows Visual Studio, you got everything. So.
Good. Sounds pretty good. So what do we talk about some of the new features, right? Like what exactly are we getting now in F# 4.5?
Yeah, absolutely. So first of all, you get some new version numbers. That's not a language feature, so to speak.
Sure.
So for those of you who have been following like C#'s progression and .NET Core's progression with some of the new stuff involving span, which is sort of this low level, basically it's sort of a pointer and an offset somewhere in memory. This is, and like there's all sorts of like safety features and efficiencies sort of built into the runtime for this sort of construct, and it's been surfaced as language features in newer C# versions. Well, we did that exact same thing over in F#. So I think the granularity that I chose was about 9 features around spans by itself.
Really?
I'm not going to talk about every single one of them. So like, we introduced the concept of a void pointer in F#, but like that's just sort of something that you'll just kind of use if you're doing more advanced programming. But
so really quickly, why don't you tell us what exactly is a span? Like what are some of the use cases would you use that type of?
Yeah, absolutely. So basically the scenario is you want to do high performance stuff without having to drop down into native code. Like with C++. And so, I mean, there are a lot of scenarios where you got to do that anyways. So like, that's not something that you should necessarily avoid at all costs. But there are a lot of people who are saying, yeah, but I just want to not allocate a ton and a ton of strings by doing like really basic programming. And so we sort of said, okay, is there a way that you can do this sort of stuff in managed code and sort of have like, the safety benefits that you get in .NET, but you still get a bit more of that native performance. And so the way that you sort of accomplish that is you restrict sort of the things that you can actually do with these constructs.
Gotcha.
So if you look at this code sample right here, you'll notice there's 2 things here. There's this inref and outref construct, right? An inref right there, and sorry, not outref, I meant byref. Right, so all a byref is, it says represents a managed pointer in F# code. And that's all it is. So this is just a pointer that exists somewhere. And so if you've been doing C programming or C++ programming, you know that pointers, you can do all sorts of wacky stuff with them.
Right.
And that buys you efficiencies, but like it's also very unsafe. So this basically says, okay, well, you can do a lot less of the wacky stuff, but you get a lot of the safety. And so if we walk through some of this code here, I just have a really basic function called print that just takes an inref event and then it prints it out. Right? But say I want to do something unsafe, well, not necessarily unsafe, but something that you wouldn't expect. So inref is basically a read-only managed pointer. Say I want to go, okay, well, I'm going to mutate that to be the value 12. Well, that doesn't work.
Right.
Right? So I get squiggles there saying that this is read-only, so the write is not permitted. This is the sort of thing where, sort of because F# uses type inference very heavily for things, when you start using these constructs, we will infer to the inref as much as we can to basically sort of, because we are immutable by default with all of our bindings, so it would also make sense for our pointers to sort of be read-only by default if you're relying on inference. So in this case, I specified the type explicitly, but this is, an inref is what you're going to see a lot in F# code. And so you'll run into that. Now, if you are actually doing something where you're like, yes, I want to mutate the value, then you use a biref. And a biref is just like, it's read-write. And so in this case, like I could print out the value, I could set it equal to itself times itself, and then print it out again and do something like that. And so the way that you use inrefs and birefs varies very slightly. So in this case, I've defined a value called num, which is initially a value 12. And this is an immutable value. Like I can't change this without the code compiling. But I can still actually pass a reference to that, like a pointer to that value to the print function. Because print, it's just a read-only thing. So I'm not actually going to be mutating it. And so the way that you actually do that is you just use the ampersand keyword, and that just says, OK, take a reference of this, which is in this case a pointer. It's the exact same way that you would pass by reference in F#, which coincidentally also uses the biref and inref constructs. It's just we're sort of saying not only is it for pass by reference, but it's for all this sort of stuff.
Got it.
For the second function, I can't just do this. Right? Say I delete this. This is not going to work, right? Type mismatch. Expecting a biref, but I gave it an inref. Right. I'm basically saying, oh, treat num as an inref because this is effectively using type inference and saying, okay, well, treat this as what it is. It is an immutable value, so we turn it into an inref. So what you need to do is you need to actually establish something to be mutable up front if you want to pass something in as a biref. Because that's sort of, OK, this value can change, so then I'm going to use the construct that allows you to change things. That's sort of the way that works. And then there's also one thing that I want to call out here, an actual intentional compiler error. So we also have scoping rules for birefs. This is something that's entirely new in F# 4.5. So say I want to define this value x that's a biref, and then inside I want to define a value y that's mutable, and then it doesn't necessarily have to be mutable, but then basically say, oh, return the reference of this internally defined value. Well, that's actually sort of an unsound thing. Right? Because being able to say, oh, give me a pointer to a thing that I defined in a scope that is now effectively finished, right? So like this right here, say you were to do something even more dangerous, like let mutable y equals 12 and try to have it escape its scope like this. Well, it's for the same rules. This is not going to work because it was defined within the scope of this function, so I can't just have like this pointer pointing to this thing that like is effectively being reinitialized all the time. Like that's something that'll just lead to crazy bugs. Like you're very likely to end up crashing your application if you depend on that, and for some reason. So that's why we just make it a compile error straight off the bat. So we sort of restrict your usage of this stuff, but with that restriction, you get certain efficiencies, and you can sort of know that you're not going to completely blow up if you do that.
Right. So I think you get some, the compiler now is able to optimize some of these operations now because it knows exactly, am I mutating this thing or not? And then too, like you said, you get like some of that safety, right? Some of those safeguards around, hey, let me not shoot myself in the foot by doing some crazy pointer arithmetic.
But speaking of things that you can do that might still be a bit unexpected. So I got this fun little function called sequencinator 5000.
Sequencinator 5000. Okay, what does this do?
So this got just an array of numbers, just some values in it, and then I just have a two-string override inside of this class that just basically just string.joins a space in between each of the values. And then I have a method in here called find largest smaller than target, right? So basically, given an int, find the largest value that's still smaller than that integer. Except there's a key difference. You'll notice instead of passing a value that corresponds to, okay, hey, I found the index, I'm going to pass the value that's back with that. I'm passing a reference to that value, which is actually a pointer to that space in the underlying number array. And so what's interesting there is if I use it, say I set my target to be 16, I'm actually going to be doing a byref return for this method. So rather than just returning the value, I'm returning the pointer, and I can treat that as a reference that I can then mutate. So let me just run this to sort of show you why this is interesting.
Sure.
We'll start without debugging here. I think I set the correct one as startup. All right, cool. So the first one is 1, 3, 7, 15, blah, blah, blah. But then you notice it's 1, 3, 7, 30.
Right.
This is a bit different. The reason why is because I use that same ampersand right there. And then I invoke the method and I get the result. And then I change it to be itself multiplied by 2. In this case, I'm not grabbing a value and then just changing that value like just inside where I'm at right now. I'm actually saying, no, mutate the thing that's in there.
Yeah.
This is a sort of pattern that's used for like Unity and sort of other game programming and things like that. That's at least one of the major use cases. And so this is something that C# has supported for a bit, and we supported consuming them in F# 4.1, but we did not support production of these byref returns up until now. So now we support both consumption and production, and so you can interop perfectly. So like you can send the thing that a C# component may be expecting, and you can do that same sort of manipulating pointer sort of stuff with Unity programming, which is pretty cool.
Nice. That's awesome.
Yeah, and so speaking of perf, so there's sort of I'll show like a benchmark of this. Let me sort of give you a short scenario. So imagine you got like a web server, you're processing a bunch of strings in there, and you need to do something really basic, like I've got some sort of separator, like in this case it's a comma, but it doesn't have to be a comma.
Right, I'm just doing some type of parsing, right? I'm trying to pull information out of that.
Yeah, and so this is like just a trivial function, but like you do this sort of stuff all the time actually, if you're in some sort of like high performance sort of thing where you're like, no, I know that data is going to exist at this point, and I want to extract little pieces of it and then kind of do something with that. And that portion of extract little pieces of data out may very well be a hot loop in something that you're doing, and that could actually be a bottleneck. So like sort of pretty much idiomatic F# code in this case is just, okay, I got a string, find the position of the thing, in this case it's a comma, parse out a value that's from 0 up until that position, like what's the value that's just kind of next to it right there, and then what's the next value, and then return a tuple that's comprised of those both. That's fairly straightforward. Most people should be pretty happy, but if you need to do that in a hot loop where you got just thousands and thousands, perhaps millions of strings, you can start to allocate a whole lot. So you may want to rewrite that. So this is where span of t and some of the struct and just byref like stuff sort of comes into play.
Right.
So the way that you write it is actually almost identical. So in this case, I'm just going to have a span. And I'm just going to take str, and I'm going to go as span in this case. So that's a member that's sitting on string, right? And so then I'm basically just going to write this exact same code right here. Okay, but then instead of string, str.indexOf, I'll just do span.indexOf, and so on. Let me just copy and paste that, save you, my terrible typing there, and in this case, this will be the slice method rather than the substring method. Oh, there we go. And
you gotta change that one to spans here.
There we go. Yeah. See, compiler helping me out, but I didn't even bother to look at it.
Right.
And then one last change, rather than a regular tuple, because regular tuples in F# are reference types. I'm just going to turn this into a struct tuple. So this is something that actually existed in F# 4.1. And prior to F# 4.5, you actually could write code like this, but the compiler didn't really have a deep understanding of what was going on, and so we weren't necessarily emitting all the correct stuff. So if you were to run this now, like I have some code for benchmark.net, I'm not going to sit you through that because it runs a whole bunch of different iterations, but there's quite a difference. So when I ran that actually on my Mac, I didn't even use the Parallels instance that I'm sitting in. You'll notice this little table here, the old version took almost about 4 seconds to run on average, and the new one takes about 1.5 seconds to run on average.
Oh wow,
that's kind of cool, so that's faster. But the thing that I really like is if you look at total allocated, in this case I had I think 10 million strings. I said, okay, parse out 10 million strings. In this case, it allocated almost a gigabyte to parse that stuff with the old version, and the new one allocated 76 megs.
That's crazy. I find like a lot of the perf work that's been going on, particularly in the .NET community, has been around how can we efficiently manage strings.
Yes.
That seems to be like a huge bottleneck for a lot of folks.
Oh yeah.
And particularly we're doing stuff like we're parsing like just JSON and XML and like a lot of these return types, particularly for web servers, right? Like we return a lot of these types of data types. And we don't really think about the perf that comes in along, right? Like we just say, oh, here's a list of stuff, serialize this and just send it over the wire.
Yeah.
You know what I mean?
Yeah, and that sort of stuff, like, just sort of getting your job done, just have some strings, move them through, copy stuff around, allocate new strings, that's totally fine.
Yeah.
But then all of a sudden you're like, oh crap, this thing now needs to have a really high load coming into it. And then all of a sudden all those allocations that you did, they really start to really hit you over long spans of time. Because, I mean, honestly, the difference for a single run between 4 seconds versus 1.5 seconds is not like that big of a deal. But that memory allocation is huge, because if this thing is running for like hours at a time, or basically just running perpetually, well, each time you're sort of saying, oh, I'm allocating a gig, I'm allocating a gig, allocating a gig, and then like the GC eventually has to come in and clean stuff up, and then GC pauses the world and it says, hey, I got to get rid of stuff. Right. And then you start getting hit with that, and that's where it becomes really nasty to sort of deal with without these sort of things like span. Yeah. And that's one of the big motivations for that whole set of stuff that's in the runtime and sort of surfacing that up in the language. So cool. Yeah, now you can do that all with F#, which is pretty great.
Nice, that's awesome. So what other new features we have in 4.5?
All right, we got a few other ones. It's not just all span. As I said, I didn't cover everything with the span work. Like, there's different representation of pointers. There's the actual way to represent by ref-like structs. So I'll just show this really quickly. You notice I got some compiler errors. Yeah. I'm defining a struct here, and it takes in 2 spans as inputs, and you're like, oh, that should just work, right? Well, no, because span is not just a struct. Span is a by ref-like struct. It's something that has some special locks on it, I guess you could say, to sort of says, no, this thing lives on the stack. Right. This thing is allocated on the stack. It stays on the stack. You don't accidentally have it live on the heap somehow. Right. But this struct, without specifying that it is by ref-like, gives you no guarantee that you're going to be either on the stack or the heap. You're just going to be allocated how you're allocated. Right. And so in this case, it's actually very simple to just sort of add the additional attributes. And so span is itself a by ref-like struct. And so one of the rules with these is if you want to have a by ref-like struct contained with another one, like you can't just stick it inside of a class. You can't just stick it anywhere you want. It has to be inside of another by ref-like struct. And that sort of constraints is what allows basically the runtime to do things a lot faster than it would be able to do. So
you just annotated it with a is by ref-like.
Yeah, this is just a little attribute you stick on there. And so this does disallow you from doing really weird stuff. So like you can't like start allocating stuff on the heap inside of the struct anymore. Sure. This sort of locks you down into saying, no, you're on the stack. But if that's something that is of a benefit to you performance-wise, then this is definitely a good thing. Awesome. So enough about that stuff, because perf, it's just boring. Nobody likes that, right? No. We got a new keyword, which is pretty fun.
We got keywords?
Yeah, we got a new keyword and another type here that I'm going to show at the same time. People who use F# know about pattern matching. It's usually one of their favorite features. Yeah. They also know about the option type. Some of V or none of V. It's basically a way of representing either something can exist or nothing exists. Yeah. That optional type is a reference type, and we wanted to have a struct version of that. So we have it, it's called value sum and value none. It basically works the exact same way. It's a struct rather than an option, rather than a reference type. So if you're in sort of one of those scenarios where a struct is of a benefit to you, performance-wise or whatever, then you can use that, and ta-da. Not like a really big feature, but just something that people should be able to make some use out of. Gotcha. But one of the things that people seem to really love a lot when this came out, and what's cool is this is actually a full community contribution, is the new match bang keyword. So I got this highlighted right here. Now this is slightly different than the match keyword. So I'm going to walk through the first one. So this first one, match, under try parse int async, because obviously you need to be asynchronous to parse an integer, right?
Right.
So I'm just going to try parse and then produce a value sum if I got it. Otherwise, I produce a value none. And so this is just OK. Match on the value. Pretty straightforward. Most F# programmers know how to do this. All over the place, it's usually one of the first things you learn how to do when you're learning F# in the first place.
Yeah.
But this is sort of an asynchronous option, right? This isn't just a value option that's being returned. This is an async of value option. This is a thing that's wrapping around it, saying, no, this thing exists in an asynchronous context.
Yeah.
And so to extract the underlying value, you need to extract effectively out of that context. And that's something that if you tried to write without the match bang keyword today, like say I just got rid of that, well, this isn't gonna work because I was expecting a value option, but instead I got an async of value option.
Right.
So this basically just does that sort of unwrapping. And so normally you could write code, like you could do something like let bang v equals try parse int async str, and then v itself is going to be a value option. And then you could match on v, but that's just kind of boilerplate. And so you could just sort of inline, make that call there. That kind of simplifies a bit of extra code that you need. So
nice.
Yeah.
So I want to go back really quickly. So you said that this was a community contribution. So could we talk about that really quickly? So how does the community go along the routes of, oh, hey, I think this is a cool feature, and I'm guessing F# is open source, right? So we could put it on GitHub and we make a create an issue, and then we start discussing it. Is that
yeah,
how?
so we actually have a full process in place. So we have a repository called language suggestions. And in the language suggestions repository, you basically just file an issue saying, hey, I think it'd be cool if you do this.
Yeah.
And we have like a template that's sort of like, it asks you questions to sort of like, say, hey, summarize like what's the thing that you want? What are the reasons why you want this? Have you considered if this is a breaking change? Like things like that to sort of get people to think about the problem a little bit.
Yeah.
And then there's a discussion, and what we'll do is we'll go in, we'll sort of talk through it. If we think it makes sense, we'll mark it as approved in principle, which is a way of saying, we think this would make sense to exist in a future F# language version.
Right.
And then from that point forward, it's completely open for anybody to say, oh, well, I can write a spec for this. So if you write the spec, we have, or an RFC as we call it, we have another RFCs repository where everything's sort of organized like, by, we have past RFCs for past language versions where they're all organized in a little folder. And then we have just a regular folder called RFCs where anything that's an active spec that has not shipped yet exists. And so you can just add a new file there. And again, we have another template and we sort of say, okay, we basically track back like, what's the suggestion that this sort of writes a spec for? And then, can write out everything there, like what's the motivation, what's the summary, what's the detailed design, what are some additional things to consider, what are some alternatives that you may have thought of, what are some potential drawbacks to doing this feature, things like that. And then once that's sort of fleshed out and in place, we'll merge it and we'll say, okay, the spec is sort of there, and then it's sort of up for anybody to implement the actual compiler feature.
Okay.
And so in this case, we had an open source contributor, John Wastenberg, came by and he said, yeah, I'd like to do this. I think this would be pretty cool. And so the community talked about the match bang keyword. They all seemed to kind of like it. And then he said, all right, I'll write the spec. So he wrote the spec. And he said, OK, well, I guess I'll write the pull request. So we wrote the pull request.
Nice.
And we worked with him sort of each of the stages. He was really, really good. When I say we worked with him, we barely had to really do much, just sort of said, he would ask a question like, oh, hey, how do I do X? And we'd say, OK, just go right there. And then he'd go right there and then implement it. And it was of high quality. So
that's awesome.
We decided when it was time to sort of grab the things that we felt would make sense for F# 4.5. We said, OK, this is an open pull request that is complete. Everything seems to work. All the tests passed. We tried it out. We think we like it. Let's bring it in. So we brought it in. And then, boom, it's in there. And we get to do probably one of my favorite things, which is when I write the release notes to sort of explain like something that came out in the next Visual Studio version or something, is specifically attribute him as the person who implemented this whole thing. So that was pretty cool. And since then, he's actually implemented other things and submitted other RFCs, other issues, that sort of stuff. So that's sort of how the whole process works. And that was something that I think was really cool, is just end to end from the beginning all the way until actually shipping. Like this was a full community thing that we just sort of guided, along until now everybody can use it. So
yeah, and it's really empowering for your community too to see, hey, this is not just something that we talk about doing, like open source. This is real open source.
Yeah.
Like, you can contribute. You could, you can make suggestions. You could be a part of the discussion.
Yeah.
And then eventually you could chip inside a Visual Studio.
Yeah. Yeah. No, exactly. And what's interesting also is he actually did not use Visual Studio to implement any of this because he has a Mac.
Okay.
And well, so he used VS for Mac, but like he didn't use just VS for Mac. Like he was using the CLI. He was using VS Code, that sort of stuff. And so it was also cool that not only was this a community person, but this is not someone who was using Visual Studio for Windows, sort of the old sort of association that you would get with .NET and F#. Like he was fully like in sort of this new cross-platform world, doing it all end to end, which is really awesome.
Dude, that's awesome, man. This is so great to hear. So I know we're running low on time. Do you have any other cool little features we could show just before?
Yeah, just one little thing. I got this little project called Relaxations because I like to relax.
Relaxation. I like that.
So there's this. These are just two little. I guess you could say the compiler was just a little bit too nitpicky prior to F# 4.5. So in this case, I got an objects, basically a list of objects, and so strings are also objects. So due to the rules of inheritance, you can say I have a list of objects, and then it's comprised of strings. Well, if I wanted to combine that string character with this yield statement, yield expression, I would actually need to explicitly cast the object prior to F# 4.5, which is just kind of annoying because, like, logically, strings are objects, so it should just work.
Right.
Well, in F# 4.5, it just works. You don't have to.
You have to do that cast anymore.
Yeah, and then another one. So you'll notice there's some indentation going on here that might sort of throw you off a little bit. Like I have this starting bracket here. For this array, except it's actually tabbed over rather than sort of being right here.
Yeah.
That's because in F# 4.1 you had to actually do that. And so people would write code that looked like this, which I think looks totally fine. There's sort of no reason for this not to exist this way. But the compiler would say, you got a bad indentation. And they're like, that doesn't make any sense. So in F# 4.5, we just made it so it doesn't do that anymore. And this is actually something that should help out people who use the Fable compiler, which is an F# to JavaScript transpiler. And it has sort of a way to use F# syntax to model like a DOM tree. And so the way that you would syntactically model that is you oftentimes align stuff sort of vertically like this. And so people would want to do that, and then the compiler would yell at them. So that's just sort of a nice little goodie for people who are doing especially that sort of stuff. And yeah, those are sort of the little relaxations of syntax that we have with 4.5.
Cool. Well, this was awesome, man. Like, thank you so much for coming on the show, man.
Yeah, absolutely.
So this is another episode of the On.NET Show, and we just had Phillip telling us all about the good stuff that's inside of F# 4.5.